right. You're ready?
My dream is to sleep.
All right, today we will be working on inverse functions. Inverse is the keyword. So why don't we take a look at where inversing happens? Why do we need to inverse things, right? All right, here's one pretty good example. If you travel outside the United States, you need a different currency, of course. Most countries won't take your currency. So, for example, to Europe, to travel to Europe, they use euros. In the airport or in your first chance, you need to go in those exchange offices and hand over whatever money you want to spend, and they will give you back money in euros. And the current rate is computed by, current exchange amount is computed by this function. Whatever amount you have in your pocket is multiplied by 0.8, such as $100 turns into 80 euros, 250 turns into 200. This is a table of some sample values. But every trip has a return trip, right? You need to go back home. So before you leave that country, in the airport, you need to change whatever euros you have in your pocket, change it to dollars, unless you want to keep it as a souvenir. You don't want to keep 200 euros as a souvenir, it's a lot of money. So you may want to change back. So you need an opposite function to take it back to dollars. And this is called inverse function. And in this section, we are going to see how they have figured out this inverse function. Once you're given the original one, how did they get that inverse function? It looks like they just divided by 0.8, right? Is it always the division? No. It's not always this straightforward. There are some steps involved, and you may sometimes never guess the answer. Here I can guess. I need to divide by 0.8. Fine. But sometimes just division or simple operations won't work. Okay? So we will see about that, and in the next section in this chapter, we will see about exponential functions. And the following chapter, exponential functions, we'll see logarithmic functions. They will be inverse of each other. Okay? So that will be chapter 4. But before inverting functions, there are some requirements. We will first examine what kind of relations we have between original and inverse functions, and then figure out that requirement. And I will show you a test to check out that requirement condition. Okay? So, first of all, what does inversing mean? You have, in the original function, there is a dollar amount changed to euro, right? In the inverse function, you flip y and x values. So 180 turns 80 and 100. Inverse function actually invert the location as well of x and y. It totally flips x and y. That's first notation, first observation. Secondly, in the graph, the original function is, which one is original? Blue one. You have $200 turning into 160 euros, 100 to 80. This is blue one is original. What happened to blue one when they inverted it? Usually most people think, oh, it's going to go back under x-axis. They just flip it across x-axis. That's what they think inversion is. But no. It's actually you put a dashed line, which is y equal x between x and y. And you take symmetry of each point. Look. This is a 90-degree angle. You take symmetry of each point across this y equal x line. Or, if you want to take it from another angle, it's symmetry, but this is actually what happened. You flip 200 and 160, and what happens when you flip them? 160 comes first, 200 comes next. So you find 160 and 200 and make that dot. Okay? Every time you take a number, their coordinates and flip them. 180 becomes 80 and 100. Okay? So such as if you have a value like 350, it's gonna turn into 50 and 300. That's how I locate its inverse. Okay? So a point here turns into a point there. So you kinda, again, the idea is you take opposite of this point, symmetry of this point across y equal x. So second observation we obtain is, if you want to find out the graph of the inverse of a given function, all you need to do is take symmetry of that picture with respect to y equal x line. Y equal x is extremely important. Okay? 2 observations. Alright, here is another one. Okay, let's take a look at the next example. Alright, please focus on this part. Now, what do you see here? I will try to build an example out of this, such as you go to another country, $1 turns into 3, like Turkish liras. In Turkey, they give you 3 liras for each dollar. And then a minute later, you go back, oh, you notice you have $2 more in your pocket and you want to change it again. And the guy is, again, giving you 3 liras, 3 new currency. So what's wrong here? You feel like you're ripped, right? Because earlier they give you 3 liras. Now they are giving you also 3 liras. This happens in real life. I mean, you go to another shop and they give you even less. Okay, they rip you off basically. But, okay, if you want to invert such a case, what do you have to do? Inverting means flipping the order of this coordinates of this point. This point was 2, 3. Now it happens at 3, 2. When I flip this, change the order, it turns into 3, 2. It's this point. This point comes here. And same way, this 1, 3, this is 1, 3, goes to 3, 1. Original graph, the new inverted function, inverse function. But what happens to inverse function? When I go through a vertical line, it crosses my function at 2 points. What does this say? Whatever the rate table they use, rate function they use to change my dollar to that currency has a flaw. It's not right. I know it's not right because I substituted 2 different amounts and gave me the same money. I know there is flaw, but this is the mathematical reason. The inversion function, inverted function, is not actually a function at all. You cannot cross a function graph with more than 2 points in a vertical line. Okay? So what I'm saying here is, in a function to be inverted, to have an inverse, you must not have 2 points on the same horizontal line. Look, these points are on the same horizontal line. Kinda, you are giving $1, $2, or $10, you are still getting $3 back, or 3 new currency back. Impossible, okay? So in a real life, this is spooky, alright? And in math, these functions are not invertible. So not all functions are invertible. This is one of them. So what is this condition called? This condition called one-to-oneness. And this function is not one-to-one. Because 2 different values going into 1, of course it's not one-to-one. One-to-one means each different value goes to a separate value. Can't go to same place. So what's happening in this function is, again, $1 is going to 3. $2 is going to 3, which is not one-to-one. Each arrow must be assigned to separate value. Okay? Make sense? Alright, what is the formal definition though? This is the verbal definition. Each arrow must go their own way. A formal definition is, if you take 2 different values, this means different. If A is different than B, if they are not the same, then their values must not be the same. Look, different, right? Different values. but same value they are going. It can't be the same. It says must be different. So this is not function one-to-one according to this description. However, when it comes to using this definition, we don't use this one. We use the equivalent form. This is much better. Because we are not comfortable with working unequal sign. This is unequal. We are not feeling comfortable working with this. We like equalities better. So we flip this. This is talking the same language. It says if the function values match, those two numbers entered must be the same. They can't be different. Because their answers formulas are matching. So those two numbers must be matching. So please know this one. We start when you set two function values equal the same, then those numbers must be the same. That's what one-to-oneness means. But usually what one-to-oneness means, when you look at it in a horizontal line direction, no two dots must be side by side. Or in other words, we call this a horizontal line test. You should never be able to cross a curve with a horizontal line in more than 1 point. If you have two or more, then we call it not one-to-one. Again, one-to-one means you can only cross at most once, never more than once. Okay? Make sense? So when you have a graph, it's easy to test. This is crossing twice, not one-to-one. By the way, this is the shortcut to say one-to-one. How about this one? Let's cross all the points you can spot with horizontal lines. Can you cross more than once? No. This is, of course, one-to-one. Okay? Clear? Called horizontal line test. You draw as many horizontal lines as you wish. You can keep doing this all day if you wish. But these are not even touching once. We shouldn't be touching twice or more, okay? Only once, at most once. Alright, there are two questions here. Neither of them have a graph. I wish I had a graph so I can cross them with horizontal lines and answer them. No, we didn't have anything. But they are still not too bad. Because all you need to do is check if each arrow from left to right is assigned to a single separate value. What arrows do I mean? Some people like sketching these Venn diagrams. This is called Venn. X values going to Y values. X's are the domain values, or the values in the first components, which is 7, 4, -6, and 9. Y values are the values showing up in the second component, which I haven't circled yet. The red values. All you need to do is check if every number going into a distinct number. No two values must go to the same. All right, -1, 1, 7 and 4 going to -1 and 1. Right? How about -6 is going to another one, okay, which is 2. 9 is going to where? -3. Do you see two arrows going to the same location? Do you? Everybody is going into unique destinations. Passenger 7 going to a different address than 4. Yeah. So this is called a. Am I making a mistake? What is this called? It's called one-to-one. Right? 7, 4 -6. Some people look at me skeptical eyes, but all different, right? This is called one-to-one. All right. This is one option. Watch and track the arrows. Another option is if you really want to do horizontal line test, then really plot all those, how many? 1, 2, 3, 4 points. Okay? So how can you plot this? 7 minus 1 is somewhere here. 4, 1 is about there. Minus 2, minus 6, 2. Nine minus 3. There. Any of the 2 points crossed by a horizontal line? No. This one, that one. None of them are crossed, right? So if you really want to plot them, you can plot if you wish. But it's just waste of time in my opinion. Alright? If you don't want to do any of these and directly answer right on the list, what you should be checking for? What you should be checking for? If you want to answer right here without any of this demonstration. Anthony? What's that?
Repeating Y values?
Yeah, check if there are any repeating Y values. Any repetition here? Any? Now all this thing, we're good. Same deal here. Any repetition here? Yes, this time we have a repetition. Look. 2 guys are going to the same location. If you want to plot them, minus 11.5 and 0.1 are both going to the same place, which is negative 2.3. Okay? So 2 different values going to the same. This is not 1 to 1. Okay? You can even plot these values here. You will see these are on the same level. 2 different x values on the same level. It's not 1 to 1. You cannot get inverse of these functions unless you fix it somehow. There is some fix for some functions. We will see later. Alright, it's time to apply vertical line test quickly on the 3 separate questions. Alright, 1 to 1 or not? Not 1 to 1. 1 to 1. 1 to 1. Anyone supporting not 1 to 1? Maybe you're right. No, it's 1 to 1. Look, I can't cross it more than once. It's always single touch. This is 1 to 1. How about this?
No.
Just one example is enough. Touch, touch, touch. 3 touches. I mean, it's 3 separate dollar amounts going to the same euros. Impossible. Not 1 to 1. Alright, how about this one? 1 to 1 function. Agree? Agree? I just want to make sure. This is a 1 to 1 function, you're saying. This is a trick question.
Can it still be a function of multiple x's?
Yeah. It's not saying it's a relation. Here it was saying, are these 1 to 1 relations? And that's one function. So look at the wording. You are not only checking 1 to 1ness here, but also function. It needs to be a function. So is this is 1 to 1. It's a 1 to 1 relation. But is it a function as well? Now, to check function, you must not cross it more than once. I'm crossing it how many times here? Look. It's like single passenger one is going to 3 different addresses. You cannot separate a body of a person into 3 pieces and drop it in every address, right? Unless you're a serial killer. But you're not, right? So we're good.
Then number one.
What's that?
Then wouldn't number one be a relation? So it goes down the.
Good question. Is this a function? When you take a deep look at here with a magnifying glass, okay, let's say you magnified it, it's always like this. It's always one touch at a time here. It looks like almost these are overlapping, but no, it's not really, okay? So it's really one touch. When you cross it, you can only cross it in once. So it's a function. This is a function. This is not one-to-one. I'm not even checking it's a function, okay? This is not. It's one-to-one, but not a function, so we'll call not one-to-one function. One-to-oneness is something we are interested in functions. We will never actually, one-to-one relations are not actually interesting. Why are we checking one-to-oneness again? To invert them, get inverse of them. And inverse of things should be functions. Functions are the interesting stuff in this course, not relations. So they are linked to each other, okay? Make sense? All right. What happens if you are given the formula of the function and you don't know how to sketch it? I know you can sketch this. When you sketch this, what kind of shape do you get? This one, it has no square, only x and the numbers around it. This is called a line. It's a linear, first 4 letters line. You're gonna get a line here with a slope -3. And everybody knows lines with non-horizontal lines, either decreasing or going up lines, are always one-to-one. So I know this is one-to-one, but they are saying, don't use the graph, use this definition instead in both questions. How do we use the definition? Theory of one-to-oneness, not the application, visual application, but use the theory, this theory, to prove you are now a real mathematician. You're going to prove this is one-to-one without sketching it, without drawing diagrams, circles, only by that fact I circled. Okay? So let's start with what it says. This is what you need to prove. You assume this, you accept this. It says if this is true, so we start with assuming this, and we need to arrive at this result. Arrive at this fact. So you start with this, so this is start. You must end with this thing. Start, end. Okay? So this is your start. And do some algebra, blah, 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 blah. In the end, I want to see only A equals B. And start is f of A equals f of B. If you can go from start to end with only allowed operations of math, regular, reasonable math operations, you can go to this result. Then mission is complete. We call this one-to-one, and we shouldn't be having any issues here. However, for this one, I'm not promising anything. Let's see if we can go start from f of A equals f of B and go all the way to the end. Okay? Now, how do we start? Just compute f of A and f of B, please. Oh, by the way, our function is k. May I switch to f, please? I'm using f notation. Let's say this is f. If f of x, you see x here, is minus 3x minus 2, what is f of A? If you see A there instead of x, what is it?
You put an A in where the X would be.
Exactly. If you see something else, even a turkey here, you make this turkey, right? So minus 3a minus 2 is what I make here. And I claim they are equal. This is given. I take it granted. This is given to me. Thank you. Okay. And now I see f of b, so I substitute b there, right? Alright, this is the target. Always keep this in mind. I need to get a alone on the left, b on the right. This will prove me f is 1 to 1. Okay, I'm not quite there. I have 3 and 2. I wish these were gone. So what rules of math can we employ here to get rid of 3 and minus 2? What? Next step, what would you do? Add 2. And this is quite simple, right? You've been doing that for equation solving. You can add 2 to both sides, correct, in math? Of in any equation? Okay. Next. Divide by 3. Mission accomplished. We are done. Look what's left. A equals B. Proof is over. F is 1 to 1. Conclusion is. This is how the mathematical proof is done. This is the tool they've given us. Show this, we're done. I showed it, you're done. Let's go to the next question. Any questions on this one? See what's going to happen on this one. Again, what is start? We again assume F, but this is not F. Let's use Q this time. QA equals QB. I start with this. Q of A equals Q of B. And what is my end? End goes down. Alright, I want to end up with only A on the left, B on the right. We're going to fill in the middle part. How do I get Q of A? I just enter A everywhere again, right? So it is A minus 2. And this is B minus 2. Alright. Here is my steps. I need to get rid of these 2 bars around it because this doesn't have 1. I need to get rid of 2, minus 2. Then the mission will be over. Now which one is first? Can you get rid of minus 2? Can you? No, not before breaking these walls. You cannot access the minus 2. It's protected by these walls. Now go back to chapter 2. We solved absolute value equations. There was a fact there. If there are absolute values around each side of the equation, how do we remove those absolute values? Anyone remembers? Look, if it's just one absolute value equals 3, this is easy removal. Just you put once with a plus, once with a minus. You put plus and minus on the number side. I'm saying you have absolute values on both sides. Both sides have variables in it. Similar though. Similar work. You know how? You can't do it in one step. Once you remove everything around them, both sides, all absolute values vanished, and no change in the inside terms, nothing. You just copy them down. Second, you keep the left side the same and put before the right side negative. Same deal. I pretty much did the same thing. I removed this, kept this positive. I removed that again, kept this negative. Look, remove, remove. Once with a plus, once with a minus sign. Okay? Now, do you see already the failure here? Do you see the failure? So we created 2 equations out of 1. Now let's try to solve it as if we haven't seen anything weird. Let's try to leave A and B alone. Alright, I will repeat the same work. Oh, I got A equals B. Mission accomplished then. No, there is another side of the story. This is gonna bring minus b plus 2, right, when you pass this. And we will have, I can move this to the other side, b to the other side, but you will never get rid of these constants. Like if you try to add both sides plus 2, this is gonna rise to 4. A is minus b plus 4, for example, and you can never get a and b alone, never. So what does this say? If I assign a value to q of x like 5, there will be 2 different values making that 5 value. One of them will be whatever you choose for a and b, you set them equal. The other a and b is you add negative, whatever b you chose, add 4, and then you assign b. So there are 2 different a and b values making the same thing. If you want to test, check, for example, substituting minus 1, okay, and you get minus 3 and plus 3, and substitute what other value do you get? 3. 5. Test 5. Look, minus 1 minus 2 makes 3. 5 minus 2 also makes 3. You got two answers giving you the same q value. So, anyhow, this didn't happen because you had 2 solutions. So not 1-to-1. Okay? So absolute values, we got our lesson. Absolute values are troublesome. When you see absolute values, beware. They tend to be not 1-to-1 because you get double solutions. 2 different x values give you the same result. They go to the same address when they write on this Q bus. So it's not invertible. Another type of functions you need to watch for is square functions. If this was x squared, when you try to go back, you get plus and minus again, 2 solutions. Okay? Or any kind of even powers of x is troublesome. I think we're going to see an example about that when we are evaluating inverse. I think we're going to get that. No, I didn't take one. No, we got the square root. No. Any questions so far? I know this is a little theoretical, but we had to teach you this. In case you can't graph this and you want to find an answer by doing algebra, this is the algebra proof you are supposed to make, okay? All right, now let's say you have 2 functions and you believe they are maybe inverse of each other. Maybe. You want to be sure. What test can we apply? The test is called composition. You compose those 2 functions in any order. F is first, G is next, G is first, F is next, and they need to be only x. The result should be x. Okay, let's take a look. There are 2 candidate functions given here, and they claim they are inverse of each other. We don't know yet. We are going to determine that. All you need to do is, if you want to test 2 functions are inverse of each other, is compute this. Do the work and compute this. You must be left with, after a while, only x. They must kind of cancel out, consume each other, and only leftover item, survivor, should be x. Well, is this all? No. You need to flip order and test again, and you also get x, then yes, for sure, 100% sure, these are inverse of each other. If one of them fails, we go ahead and call them not inverse of each other, okay? So I will fill in the details. Like remember the conversion rate formula, 0.8x and x over 0.8, they were inverse because they verify composition operation between them. All right, let's see if these are gonna check out. All right, do you remember in 2.7 how we do these circle operation? This is not multiplication. Don't try to multiply them, because they won't make x anyways. To multiply them. This is not multiplication, it's composition. That means h is out, k is in. Okay? We first compute the inside, k of x. It's not actually computing, it's just figuring out. It's just copying and replacing. What is k of x? It's given to us. You just enter this given quantity for k of x under the value of h though. This is all happening under the control of h. It's inside h. H is kind of captured them, okay? So why don't we put it back in here? Okay, what is next? I see now h of stuff to be computed, And what is given here? Again, once we use something, we use this, we will never use this again. What is the leftover item we haven't used yet? 6x plus 3. I believe we're going to use this. This is h of x. How? How are we going to use this? Any ideas?
Put it in your x's.
What?
You're going to substitute x.
Yeah. The key word is substitution. We are going to remove all these x's in the first equation. In h, I see h, remove all x's and make them something else. Because these x's work if you see x here. This is no longer x. So I'm going to first empty out, make these disappear. 6, it disappeared. And bring back whatever you see here. You always copy whatever you have, see here to there. I see now x minus 3 over 6. I will enter that here. Does it make sense? Okay, what's next? We need to now work this equation out. And what is our target? What you're trying to prove? Everything must cancel out to x only. So what is canceling out here? Look. Can I cancel these? One on the top, one on the bottom, multiplying, cancel. And we have only x minus 3 left. And we're adding another 3. The total is x. Okay? Now, I'm 99% sure these are inverses. If they check out, this first one check out, 99% the second part will check out as well. So this is kind of waste of time. You have to do it anyways, okay? It's good exercise because we are reviewing circle operation, composition operation here. So the order is flipped now. K is outside. So the first thing you're going to do is copy. Again, this is just copying. You're not computing anything. Copy whatever you see for h of x. What is h of x? Just copy it. Is it this one? No, this reads k. I need h of x. It's here. This guy. So 6x plus 3. Let's copy. Look what you have inside k. It's no longer x. It's no longer x. K of something not x. So you need to first copy the entire formula of k of x. Only the difference is skip x's. Put an empty box instead because I don't have x there anymore. I have something else. So what is that something else we need to enter? What is it? 6x plus 3, yeah. And guess what's going on again? Cancellations. And only 6x left on the top. So guess what? Another cancellation x. As I promised, both answers x. So that means the two functions are inverses. That's the conclusion. Make sense? All right. Do this one and tell me the result. Part B, or not question 9. You just POQ and tell me what you get on there. Did you get X? If you did, I will call them inverse. What'd you get? No? Anyone?
I have an answer. It's x over 2 minus 3 on the right side.
X over 3?
X over 2 minus 3.
2 minus 3. So you're saying that they're not inverses and you got this when you compose them. Any answers? Any other answers?
X minus 1.
X minus 1? That's it? Okay. Again, not inverses, but you're saying I got the different composition. Any more? Anyone found X? Okay, let's check. So again, PQX means P is eating Q of X, right? Q is under the value of P. So you need to first compute what Q of X is. Not compute, just copy. Copy Q of X here. What is it? 6x minus 3. Right here. Just copy it, borrow this thing from one line above. What is next? Now we are computing P, so you better take its equation, but leave out x's. Instead, make a box, because you no longer have x there. You have something else inside under the value of P, minus 3 plus x. I'm going to enter, no, 6x minus 3. I'm going to enter that, 6x minus 3. Alright, you better use a parentheses if there is a number before or a minus before. I don't see any number or minus, it's just plus, so you can avoid parentheses only for this case. And let's simplify this. I cancel these, I don't know how you got those answers. 6x over 6, I got x. You're all wrong. Correct? What?
You can't cancel negative 3 and 5.
Yeah, these are not crossing out. That's the part I missed. -3 and -3, they don't cancel, they actually join each other. So this was totally wrong. Cancel them. It is 6x minus 6 over 6. Now, can I cancel this 6 with these 6's? Yes, you can. Yes, you can. How? If you wish, let's take this out. Factor that 6 in front. There is a 6 common. That's x minus 1. And you can cancel it now once it's a product form. And the answer is x minus 1. Or you can break this into two different fractions with this denominator and then get the same result again, x minus 1. Okay, so this should be the right answer. Well, do I need to check now Q compose P, the reverse order? No, we don't have to because it didn't work for the first part. It's not, they're not inverse. They're not. Okay? Alright, we've been talking about inverses all 45 minutes. We haven't found one yet. What we did is checking one-to-oneness. We checked two functions are inverse or not by composition. We tested graphs for one-to-oneness. Now I think it's time to find out inverse functions. How do you get inverse function once you are given the equation of original function? How did they get that conversion rate x over 0.8 back to euros to dollars? It's all 4 steps. Simple. Almost every step is simple except step 3. You need to pay extra attention to step 3. The other 3 steps are bogus actually. Nothing serious there. By the way, for inverse functions, we use the notation f raised to the power minus 1. This reading is wrong. This is not f x to the exponent minus first exponent. It's just notation. It's a poor choice for notation, unfortunately. Math people picked a wrong choice because most people think, oh, when I have like x to the minus 1, it means 1 over x to the positive 1, or you flip, whenever you have a negative power, you flip it into positive power like this, reciprocal. And most people tend to do this 1 over f. In f is this thing, for example, they put this entire expression here and compute reciprocal of it. Totally wrong. This negative first power doesn't mean power or reciprocal. It's just notation. It's just notation to call inverse. In my belief, they should have called it not minus 1, f to the I as in the inverse. So it's most people won't confuse it. F inverse. Or maybe type in 3 letters, F, I, and V. That's better choice. Again, call it anything you wish, but not reciprocal. It's not reciprocal, okay? So once we find out inverse, we will call this by notation. But that doesn't mean it's reciprocal of this, because reciprocal of this is x plus 4 over x minus 7. That's it. You flip it and you're done. It's not inverse. Reciprocals and inverse are different. So what do? Follow these 4 steps. You'll be done. Okay? Just slow down and slowly follow each step. Step 1 says, instead of t of x weird notation, simply wipe this off and it says call it y. Okay, that's easy. I just make it y. Any difficulties with this part? We make the left side y. It's actually y. That's why we call it y. Second, interchange the word. Interchange x and y. Where is x? in two spots. Where is y? On single spot. When I say interchange, people do this. They interchange both sides and bring x minus 7, x plus 4, and y to this side and this guy to the left. So this is not interchanging. This is just switching sides. And it's still the same thing. These two are the same thing. So this is not interchanging. When I say interchange, I mean literally wipe off all x's and y's. Look, they are all gone. Now bring x's back as y and bring y as x. This is interchanging. And you're done with step 2. This is step 2. Okay? That's it. Step 3 is the real difficult part. You need to now solve for y's. Look, y's are on the top and bottom of the other side. You need to get single y completely alone on the left side, preferably. On one side, but I prefer the left side. Bring y to the left side and combine all two separate y's. So how do you bring it back to left side? How? First off, your y is in the denominator. You cannot have your variable in the denominator if you're solving it. So you need to find out a way to get rid of that denominator. How do we get rid of the denominators? Huh? Someone's saying it. Multiply. Yes. We multiply both sides by y plus 4, of course. Okay. So this will take care of the quotient or ratio. We don't like ratios, denominators. And I will pass this x to both sides. Yx plus 4x. I'm doing step 3 by the way here. And this is gone and reduced to only y minus 7. And what did I tell you? We need to bring y's together on the left, and I see a y on the right. What do? Subtract y. Okay, this is yx. Now another y comes to next to it with a negative. Okay, fine. And these are canceling as promised. We don't want to see any y on the right. So yes, promised is realized. It's no longer on the right side. Y is on the left. But I still see two different spots with y's. To solve for a variable, I need to see single of them. How do you combine kind of these two y's? Factor y, yes. If y's is common in these, and want to see a single one of them, factor them into here. Y pops up in front, and what is left instead? Here, x is left, and a minus, oh, no y left. Does it mean 0? Oh, it's still 1. Ghost 1 is still there. Okay. All right. Now, almost there. Y is single on the left. No more double y's. But I have nasty stuff next to it. I need to push everything to the other side. So which one is first? Which one and how?
Subtract the 4x.
Get rid of 4x by subtracting. Alright, that takes care of that junk. I still see y is not alone. These two combine to this. I still see y together with this mess. How do you take care of this parentheses? Divide by the entire block x minus 1. Both sides. And mission accomplished. What was our target objective? To get y alone. Again, solve means alone. We're done with the hardest step. What is step 4? Replace y by f of minus y. F of minus 1, you're done. This is a bogus step. It's just you're switching to new notation from y. The thing you obtained is the inverse. You see, the new function you obtain has nothing to do with the reciprocal of this one. It's completely different. 4x, negative 4x minus 7x minus 4. How can you test you did right? Just take a test value, such as substitute 5 and compute y value here, 5 minus 2, 9, minus 2 over 9. Now how can I test I did it right? Take minus 2 over 9 and put it in x, see if you're getting y value as 5. So you flip x and y and try here, see if it matches, then you did everything right. Otherwise you need to go check. Okay? Alright, we will continue this tomorrow.